Okay, welcome to I Square Maths Academy, where numbers actually meet mastery. Today, I want us to look at the quotient rule, applying the quotient rule to differentiate functions more than two. In our last class, we actually saw uh, application of quotient rule analyzing just two functions, u all over v. So here we are going to be looking at more than two functions. So here we have three functions of x. We have e power x, sine x, and x raised to the power of 4. So in this case, to find the y all over the x, I'll take the value of my u to be the whole of this function. That is e raised to the power of x sine x. And the value of our v to be equal to x raised to the power of 4. Now, the u all over the x, when you differentiate this, now this is actually a product of two functions. I remember when you're dealing with the product rule, we said you pick this one, you differentiate this, plus you pick this e power x and differentiate sine x. It means in this case, we have sine x. When you differentiate e power x, it gives you e power x. Then here we have plus e raised to the power of x. When you differentiate sine x, it gives cos x. So it means the u all over the x will be equal to e raised to the power of x. We have sine x plus e raised to the power of x cos x. Yes, e raised to the power of x cos x. That is the value of the u all over the x. We actually pick sine x and we differentiate e power x, we got this. And we pick e power x, we differentiate sine x, we got cos x. Now let's see the value of the v all over the x. Now the v all over the x is 4x raised to the power of 3. Yes, when you differentiate x raised to the power of 4, it gives 4x raised to the power of 3. Now coming back to the quotient rule, we said if y is equal to u all over v, that the y all over the x will be equal to v the u all over the x minus u the v all over the x, everything here over v squared. Yes, that is the quotient rule. So it means in this very question, where y is equal to e raised to the power of x sine x all over x raised to the power of 4, the y all over the x will be equal to, now you pick the value of v, and here we said v is equal to x raised to the power of 4. So here we pick x raised to the power of 4. Then now you get the value of the u all over the x. The u all over the x is the whole of this. Is e raised to the power of x sine x plus e raised to the power of x cos x. Then here we have minus. So this minus, now look at it here, minus. Then you pick the value of u. Our u is e raised to the power of x sine x. Yes, that's the value of u. Look at it here. U is equal to e raised to the power of x sine x. Then the v all over the x. The v all over the x is 4x raised to the power of 3. Is 4x raised to the power of 3. All over the value of v squared. Our v is x raised to the power of 4. So v squared will be x raised to the power of 4 all squared. Yes. So it means the y all over the x. The y all over the x now will be equal to, now the whole of this now will be, we have ex, then we have x power 4 sine x plus we have x raised to the power of 4 cos x minus, let's look at this, we have 4x raised to the power of 3, that is this, then e power x sine x all over. Now x raised to the power of 4 all power 2 is x raised to the power of 4 times another x raised to the power of 4. I remember in our class on indices, we said when the bases are equal, you add the powers. So it means here we have x raised to the power of 8. So therefore, the y dx, the y all over the x will be equal to, now if you look at this function, here we have e power x, and we have x raised to the power of 4. So it means here, we have e raised to the power of x raised to the power of 4 in brackets. Now we have sine x plus cos x because these two functions are already out. We have factored it out. So here we have sine x. We have sine x plus cos x. Then here we have minus. So we have minus 4x raised to the power 4e power x raised to the power of 3. Then we have sine x all over. We have x raised to the power of 8. Now, the y all over the x will be equal to, now you can't just cancel this because we have another function here. But if you look at this very well, this x raised to the power of 3 is common. So now we have e raised to the power of x, e raised to the power of x, then I'll pick x raised to the power of 3 out, then in brackets. Now, if you remove x power 3 from this x power 4, you'll be left with x. So we have x sine x plus x cos x. Then here we have the whole of this minus, already this e power x is out and the x power 3 is out. So here we'll be left with 4 sine x. Yes, 4 sine x all over x raised to the power of 8. So it therefore means that the y all over the x will be equal to this x power 3 will cancel this. Here you'll be left with x power 5. So it means we have e raised to the power of x in bracket x sine x plus x cos x minus 4 sine x, everything all over x raised to the power of 5. So that is the value of our dy all over dx. Thank you. So we are still going to look at using the logarithmic function to analyze this in the next section. Thank you and God bless you.